that was a great exercise on understanding what inverse of a function is, right? In the previous session, and we solved few examples, and I believe by now we have solved some of them in your textbook, and now you have like a grasp of that understanding, and you can solve the inverse of every function given to you, right? Yes, let's gather more concepts. In this section, we are going to talk about range of a function. Let's actually make the right analogy to understanding what range of function is. Remember, in the previous session, we were mostly talking about domain of a function, domain of a function. When we say domain, it's just all the acceptable input into a function. So all the inputs that can go into a function and not damage the function or not make the function undefined, all those set of inputs, every possible input, that for that range, that bag, that circle of inputs that you can put into a function and make it defined, we call them domain, right? So that has been on the aspect of input. Then what do you think would be the name given to the set of outputs? Meaning when we put the input inside, right? Each of them is going to be give different outputs. Now all the possible output that will come from them, all the possible inputs, like that circle, that bag of all the elements, how do we call it? That's what we call the range of a function. So we are much concerned about the input, right? That what we put in a machine so as not to damage it. By the end of the day, we are putting the input into it in order to get an output. It's the output that we are interested in. We want to work on it. If not, we will not even use a machine, right? The machine is just to help you get an output based on what you put inside. By the end of the day, you are doing that just because you want to get an output so that you can work on it. You can work with it, or you can do something. If it is food, then you want to eat it, right? Yeah. So the range of output that you are going to get is also of much concern. That's what we call the range of a function mathematically. So we are going to look at examples, but then before you get that, if you have watched the previous video, it will be easier to do this one, right? Okay, so why do I say it's easier to do this one? Let me give an example. So I'm going to use a basic example again. Let's say g of x. I'm tired of h of x, f of x this time. So f of x is going to be equal to s minus 4. Remember this example, right? Yes. So g of s equal s minus 4. So the domain of this function, you and I will know already, right? All real numbers. There's no exception because there's no division, there's no square root sign. Yes. So if you are new and you are watching this video for the first time, go and watch our series of videos on this topic so you can have the full understanding of every concept explained, right? Because we have a lot of them stored for you and we deliver them for you. Watch and then before you get into here. So now we know how to find the domain of this function. Now we are concerned about the output, meaning you are concerned about the range of a function. So basically, range of a function is just that set of output from a machine, from a function. That's all. That's all. Okay. How do we find the range of this function? So I'm going to change this one to y. We did that in the previous session, right? Y is equal to x minus 4. Because when we change it to y, it's easy to actually manipulate in terms of variables, right? Instead of moving g of x all the time. So we are going to change the g of x to y of x. That's what we did basically. And we did that in the previous session. Okay. So you are interested in the output. So what you are going to do is that you are going to make x, like you are going to interchange the position of these two guys. You are going to interchange the position of these two guys. That's basically what we want to do, but it's not appropriate to do it that way. Unlike how we did the previous session, because we are trying to find an inverse, right? We interchange the position and make y the subject, right? But here we are not going to do the interchange of position. What we are going to do is that we are going to make x the subject. We are going to put x at the place of y, but then not interchanging, but then we are going to actually do the process of making x the subject itself. Like previous session, we started with where y is put x there, where x is put y there. But in this section, for the domain, in order to find the domain, don't do that, but then make x the subject. Let x become the one that is outside, the one that's at the right side, right? You have to follow the mathematical process, but instead of just switching the spaces based on how everything is, right? That's just a basic difference for that. But okay, let's make x the subject. So here you just make x the subject. You don't interchange. You just make x the subject. So make x the subject. Yes. So for this particular one, y, the negative 4 go to the other side, become this, right? But then it's right to write it like this: s is equal to y plus 4, because we are making s the subject. So whatever is the subject, is best to put it on this side by default, right? That's best to read for us. So we now have this. Now, what's the range of this function? We are not going to talk about domain, right? We are going to talk about range of this function. The domain and range follow the same concept that we learned, where now you now see you now treat the y as your independent variable, like how we did it for domain, right? So you are here. If you are here in this session, meaning that you have taken time to understand our domain, how to find domain of a function. Now, if you are here to understand the y, right, what will happen is that you now treat your y as the input variable, the independent variable. Then you find the domain looking the same way as you did for the previous one. But then when we are doing that, if it's our input variable now, if y is our input variable now, and you see this expression, there's no division, there's no square roots. What the domain? So domain will be equal to the input variable, the set input variable y, such that y is a member of all real numbers. There's no exception, right? So now when you do this thing, you now see your y as your input variable. Then you follow the same step to find the domain of a function, of how to find the domain of a function here. There's nothing that changes over there. Just that the input variable, when you make the x the subject, when you make x the subject, or you make the input variable the subject, the original input variable the subject, you get the expression in terms of the output, right? Now you now switch your mind. You switch your mind to say, okay, the input variable now become the output variable, usually y, is now your output variable, your independent variable. Then you treat it as if you are finding the domain of that function. But actually, here it is not going to be called domain, but then we'll call it range. Range. Okay, let's try another example, basic example. Let me now bring back my f of x. F of x is equal to 2x over 3 minus x. So I have this radical function, right? For this radical function, first make x the subject. Make x the subject, but then I need to write y is equal to 2x over 3 minus x, just to make sure that y is equal to f of x. Okay, so now we make x the subject, make x the subject, because we are going to find the range. That's why we are doing this. So make x the subject. So what do we do? I have y multiplying 3 minus x is equal to 2x. I'm just doing cross multiplication over 1, like how we did. We are just making x the subject. So I will expand this. I have 3y minus xy is equal to 2x. This is change of subject to how to find this, how to make something the subject. GHS, right? Let's revise that. Okay. So now I need to make all the s components on the right side, because that's what I want. So what I will do is that I'll put y here and put x on the other side. So negative sy is here, minus 2s is equal to negative 3y, because I want all the s components to be on the right side, and then the y component will be on the left side. So let me clean this thing. What do I have? I have negative. Let me factorize x out. So I have x multiplying y minus 2. So I think negative y minus 2 is equal to negative 3y. So what do I have basically? What do I have basically? I can factorize minus x out, right? So minus x multiplying y plus 2. We will do factorization. Actually, you have a concept on that and do this. So we divide both sides by the negatives to cancel the negative. It become x multiplying so these ones, they will cancel out. The negative will cancel out. Then we have 3y. Okay, so x is now equal to 3y over y plus 2. So what we have done so far is just making x the subject, or x the subject. We made x the subject now. Now after you make x the subject, because you want to find a range, right? You now have to treat your input, your y, as your y is now your independent variable. So as if you are finding the domain of a function. So what do we do? So here it's a rational function. It's a rational function. For rational function, what do we do? What do we say? The denominator is having what? An input variable. So what we do is that we say the denominator is not equal to 0. Then we basically follow the same process. We have this answer. So the range, instead of writing domain, range is equal to y, because y is now seen as our independent variable. Y such that y is a member of all real numbers. There's an exception. So y is not equal to -2. That's why I say it's very important to watch the domain of a function side before you come here, right? If you have solved that and you solve a lot of examples, you have a full grasp of it. You don't even have to worry. It will just come naturally once you just practice. Then if here, over here, you just do switch, make sure that you make x the subject. After making x the subject, now you treat your y as if it's the input variable, then you do the same thing. But then just be careful. We are now finding range. You do this when you want to find the range, right? Let me solve one last example with you. So 3 x, oh no, it should be y it should be equal to, they don't even start with y, they just start with something like h of x. Then they will ask you to find the range of this function, find the range and domain. So I have 3x plus 1 all over 2, so this one, what type of function do you think this is? We are going to make s a subject. So but first I want to change the h of s to y, so that it can be easy for me to handle. So let me make s the subject. So making s the subject, I have 2y cross multiplication, right? 3x plus 1. Now make x the subject. So I'll put 2y minus 1 is equal to 3x. I'll divide both sides by 3. So I'll have 2y minus 1 all over 3 is equal to x. It's best to write them this way. X is equal to 2y minus 1 all over 3. Yeah. So now we have made our x the subject. Now you focus on the input variable. So the input, the y, as you now treat it as your input variable. So now we are going to talk about, we're not going to talk about domain, but we are going to talk about range. But we follow the same logic, like how to find the domain. Here it's going to be y is such that y is a member of all real numbers. Is there any exception? No, there's no exception. So we just stop here. Yeah, so the same thing. Yeah, just make y the s the subject and treat your y as if it is the input variable. Then you find the same thing as if you are finding the domain of a function, right? We took time, we actually took time, solve questions on that. So kindly watch that and see how well you can do. Then if you come here, you'll be able to understand range of a function very well. The only difference is that make x the subject before you do that, because we are now concerned about the output. Outputs are usually y. Remember, when they give you h of s at the beginning, change it to y so that you can easily manipulate. We talk about that many times, right? You can easily manipulate. That is the reason why. When you manipulate, then you're able to have your final answer as this. Now you treat your final answer as if a whole function with an input variable y and an output variable x. So now you find the you do as if you are finding the domain of this function, but then you don't write like domain, but you call it range, because you have done that switching and focusing on the outputs now. We said output range, right, is a set of all possible outputs that can come from a function. Okay, guys, that's it for this session. Let's continue building more concepts. Stay with us for the next video and a new concept for you to grasp.